problem 3. We're getting more and more complicated. Problem 3 is like the skier problem, except we introduce friction now. So in problem 3, we've got a box sitting on an incline. The box slides down the incline, but there's friction between the box and that incline. The same kind of setup as before, except now keep in mind that we do have some friction, and it is 0.15, and this angle is 25 degrees. Let's draw a free body diagram. Remember, when we have these slope problems, it's more convenient to choose a coordinate system where one of those coordinates lines up with the direction of motion. So we'll have the x direction line up with the slope. By the way, it's possible to do these problems with a regular coordinate system where x is horizontal and y is vertical, but you have to do a lot more vector math. It's just more steps. There's our object of interest. The gravity force vector, gravity force of the Earth on the box, points straight down. That means that our angle theta is right here. Refer to the previous video if you find that confusing. The normal force between the ground and the box points normal to the ground. Normal means perpendicular, so the normal force is in the y direction. And we also have friction. Friction opposes the motion. Since the motion is occurring along the x direction down the slope, that means friction force is in the negative x direction. Friction force between the ground and the box. Okay, so this gravity vector has an x component that has sine of theta because it is the opposite leg of that right triangle, and has a y component that gets cosine of theta because the y component is adjacent to angle theta. Okay, let's do Newton's second law. Sum of the forces in the y direction equals 0 because this box is not accelerating perpendicular to the slope. It's only accelerating down the slope. So we've got n in the positive y direction, and we've got the y component of gravity in the negative y direction. So n equals wy, which is w cosine theta, which is mg cos theta. In the x direction, we've got the x component of gravity pulling to the right, and we've got friction slowing things down. Now the friction force is mu times n. The x component of gravity is w sine theta, n is mg cosine theta. I'll also replace that w with an mg. And each term has an m in it, so I can cancel all those m's. And we get this result that the acceleration is g sine theta minus mu cos theta. Oops. Mu times g cos theta. Or if you do one step of algebra, you can write it in a more compact form like this. We distribute out that g. And for this batch of numbers, you can plug it in and you find it equals 2.81 meters per second squared. But as usual, I'm more interested in the generic solution. And in the next problem, we'll take a look at this generic solution and see something interesting we can learn from it.